So on an inclined plane, we have our object in this regard. So here's our flat surface, incline. In this case, weight typically always acts downwards, but because of the nature of things in regards to reality, we can't so much refer to this weight because we will not necessarily see its effects. On a horizontal plane, weight would directly move downwards. So typically, if this object is not experiencing like an external force, this object would just be stationary, of which it wouldn't be moving. But on an incline, something else happens. Because it's on an incline, you will see in a case where this surface is smooth, the object might start sliding downwards as a result of its weight. So we have the name for the weight which causes this object to slide downwards. That weight, we use the symbol Fs. Some of us are familiar to it as Fg parallel. So the weight component parallel, all it says is it's moving in the same direction as the incline. So in such a case as this one, we use the formula Fs, where we say mg sine theta, or weight sine theta. Then we acknowledge the one which is acting perpendicular to the incline. So perpendicular, it's acting at 90 degrees. So we have Fc. In this case, Fc is going to be mg cos theta, or weight cos theta. Some of us, we are familiar to it as Fg perpendicular. The last force which you might be interested in is your normal force, or the normal reaction. The normal reaction acts perpendicular to the surface itself. The surface is holding this object in such a direction. So these three forces are always there: your normal force, your Fs, and your Fc. Your responsibility is to be able to figure out this. So there's a case where there is no external force. So in a case where there's no external force and you're applying friction, the principle of friction, please bear in mind that our calculations are still at a constant speed. So where there's no external force, naturally our object is just sliding downwards. To avoid the object from sliding downwards, friction would need to oppose it by acting upwards. We should still be aware we still have Fc, we still have normal force or normal reaction. So frictional force typically opposes the acting force. The only force you have present here is as your object is sliding downwards. So to avoid your object from sliding downwards, friction has to oppose it by moving upwards or pulling in an upward direction. So while we're saying our speed is acting at, our speed is still constant, or our velocity is constant, you may easily say forces going down the slope are equals to the forces going up the slope. In this case, the only force going down the slope is Fs. The intention of all of this is to just make frictional force the subject of the formula. So alternatively, you can start with the one going up. We have frictional force is equivalent to Fs. Additionally, normal reaction in this case is equivalent to Fc. So you're saying the one perpendicular moving upwards is equivalent to the other one which is going downwards. So our normal force is equivalent to Fc. All of this leads us to the formula for coefficient of friction, where we say frictional force over normal reaction. There's a case where they may request you to calculate the angle of inclination. That angle is saying tan alpha equals to coefficient of friction. So this is as far as you should know related to a case where there's no force pulling or pushing our object up or down, but it's just naturally sliding downwards. You have a case now where you have an external force. An external force would be that force which is either pulling or pushing downwards. For our external force, we'll come with a scenario where we have it pulling or pushing. Let's start with up. So for pulling or pushing up, here's the scenario here. Theta. So in this scenario here, so always before you start, you should always know you always have Fs, Fc, normal force. In this scenario, you have an external force is pulling upwards. We may say this is F upwards. Considering that your force is pulling upwards, frictional force will move in a downward manner. You can represent it down there. Just to represent our forces, maybe let me just do this quickly. Already what we know is we knew that we already have Fs going down. So here's our Fs. So we're saying since we have Fs going downwards, we also additionally have frictional force moving in a downward manner. I'm sorry. So let's go. So we have this, we will say this is going to be our Fs. This is Fs. We also have frictional force. So this is our Fs. We also have frictional force. So frictional force moves in a downward direction. So the intention of all of this is to assist us as to how to make F up the subject of the formula. Saying forces which are going down the incline are equal to the ones going up the incline. So you can easily start with F up to say you have F up equals to the two forces which are going downwards. In this case, we have frictional force plus Fs. You still are aware that your normal force is still the same as Fc, because you're saying the ones going up in that perpendicular to the incline equals to the ones going down the incline. So when you refer to these, there they are moving downwards. Additionally, you are still saying coefficient of friction is still frictional force over normal reaction. So the intention of you going through all of this is to just make the formula for F up by using the forces you have on this diagram here. Your last scenario is a case where you have a pulling, you have a force which is pulling or pushing downwards, down the incline. So in such a case, pulling down, so let's start first. So we have Fs, we have Fc, we have normal force. Now we're saying we have a force, it's pulling down. This is F down. Since it's pulling down, friction will go up. In this case, this is going to be our frictional force. So frictional force always opposes the acting force. So if it's pulling downwards, friction would go upwards. So now to come up with the formula, you're still saying forces which are going down are equal to the ones which are going up for F down. You can easily start with the side for F down and just say F down plus the force moving in the same direction, which is Fs, equals to the only force which is going up, which is frictional force. You want to make F down the subject, so you'll take Fs to the other side. So thus now you have F down equals to frictional force minus Fs. We are still saying normal force is the same as Fc, coefficient of friction equals to frictional force over normal force. So in a case where maybe you would want to compare the formula for when it's pulling up and when it's pulling down, or rather you'd want to summarize it, you could easily say for F total represents the force pulling up or down. You will notice that when it's pulling up, our Fs, the sign, is positive, and when it's pulling downwards, our Fs is negative. So to summarize, you could just say frictional force, if it's pulling up, it's positive. If it's pulling down, it's negative Fs. So we're saying the positive sign refers to when it's going up. The negative sign is for when it's pulling down the incline. So this is as far as you need to know related to an incline. Sure.